Water chemistry. This is the second video lecture on water and wastewater treatment lesson. It is essential to have an understanding of wastewater constituents for designing and operation of wastewater treatment plant or water treatment plant. Let's see what are the methods of expressing the composition of solution. First method is mass per mass method. Okay, under that we can use percent by weight to express a composition of a solution. Example is 1% by weight sodium chloride solution. In a 1% by weight sodium chloride solution, there are 1% solute, that means sodium chloride. There are 99% solvent, that is water. Again, we can use parts per million, molality or mole fraction to express the composition of a solution. So now you can do this question and check your answer. Again, you can do these two questions and the answer is given. The second method of expressing the composition of a solution is mass per volume. We can use milligram per liter or molarity or normality. Because in designing or operation of wastewater treatment plant or water treatment plant, we should be able to say or express the concentration of some constituents, some pollutants, some impurities. Because of that, we should know all these things, but I know all of you have learned all these things in advanced level classes. Normality. I think this may be a new thing for you. Normality of a solution is the number of gram equivalent weight of a solute per liter of its solution. Equivalent weight is the gram per equivalent, atomic or molecular weight divided by N. N is the number of protons donated, total change in oxidation number of oxidation reduction reaction. And remember, N is a positive integer. As example, for the sulfuric acid, for 1 m, 1 molarity sulfuric acid, normality is 2N. And for HCl, it is 1N because there is 1 chloride minus and phosphate 3 minus. Therefore, it is 3N. Calcium hydroxide, it is 2N. Normality is used to express the concentration of protons or hydroxyl ion in the solution. So this is a question you can calculate here. And this is the second question that you can do, and answer is also given. And this is the third question, answer is also given. So these are some of the methods that we can use to express the composition of the solution. Density, percent by volume, percent by mass, volume ratio, mass per unit volume, mass ratio, chemical, then chemical analysis. Under chemical analysis, molality, molarity, and normality. So I got this table from table 2.3 in our textbooks. AD and Metcalfe's Water and Wastewater Engineering. I hope you may refer the textbooks, but for your exam, no need to refer the whole book, no need to refer the book. You can just refer our lecture notes, but for your knowledge, for your additional information, and for your gain, you should be able to, you should refer that textbook. Then again, I put this information for you again, because sometimes we use these terms. Let's see, this column refer dispersed phase, dispersion medium, and the common name. Look at here, suspension. Solid are dispersed in a liquid. So if a solid is dispersed in a liquid, it is called as suspension. If a liquid is dispersed in a liquid, it is called as an emulsion. You may have heard about emulsion paint. That means there is a liquid is dispersed in a liquid. Then foam. In foam, gas is dispersed in a liquid medium. Then smoke or aerosol. Solid is dispersed in a gas medium. Fog. Liquid is dispersed in a gas medium. Then we will see wastewater constituents. Wastewater is characterized in terms of its physical, chemical, and biological composition. Biological characteristics. Okay. So these are the biological characteristics. There are specific microorganisms, bacteria, protozoa, helminths, and viruses. So here you can read additional information about bacteria, archaea, fungi, yeast, protozoa, rotifers, algae, and viruses in wastewater. But no need to cram for your exam. No need to remember all these things. You should just remember. And the most important thing is coliform organisms. Okay? Coliform organisms are a type of pathogenic bacteria. Pathogenic, we can say it is a toxic bacteria. Okay, so usually those coliform organisms, coliform bacteria are available in human excreta and the human animal excreta. So in wastewater treatment plant, effectiveness of the disinfection process or effectiveness of the treatment process is measured by assessing the coliform organisms. And even in drinking water, it is essential to measure the coliform organism. If they are in drinking water, the presence of coliform organism is nil. There is no coliform organisms in the drinking water. But when you check the tolerance limits for the industrial waste into inland water bodies or marine water bodies, there is a space for coliform organism. So therefore, let's check the tolerance limits. So here you can see this is the tolerance limit for the discharge of industrial waste into inland surface water. Here you can see fecal coliform. Okay, let's see the zoom version. So here tolerance limit for the discharge of industrial waste into inland surface water. Fecal coliform is 40 mpn per 100 milliliter. Okay, you can check the meaning of mpn, most probable number or something. And let's see whether the fecal coliforms are available in other standards. Yes, so it is available in the tolerance limits for the industrial waste discharge into land for irrigation purposes. Then okay, but remember, in drinking water the fecal coliform percentage is 0. Then let's see chemical characteristics of wastewater. Free ammonia, organic nitrogen, nitrate, nitrite, total nitrogen, inorganic phosphorus, organic phosphorus, chloride, sulfate, metal. Then the most important things are pH, alkalinity, COD, BOD, and the dissolved oxygen. I hope you know the meaning of pH. pH is a function of H plus ion in the water. So this table shows you the definition of various terms used to define various nitrogen species. No need to remember for your exam, but when you go to the industry, sometimes you may need the knowledge of these things. Here, look at when we talk about ammonia gas, that means it is ammonia NH3. So if there are ammonium ion, that means it is a NH4 plus ion. If there are total ammonia nitrogen, that means it is the summation of ammonia and the ammonium ion. Nitrite mean NO2 minus, nitrate mean NO3 minus. If there are total inorganic nitrogen, that means there are ammonia, ammonium ion, nitrite, and the nitrate. So then there's another measurement, total gel-dal nitrogen. Gel-dal apparatus is used to measure nitrogen. So total gel-dal nitrogen mean organic nitrogen and ammonia and ammonium ion. Organic nitrogen mean ammonia and ammonium ion. Okay. Then total nitrogen mean organic nitrogen and nitrate and the nitrite. So I will discuss this in our next section, physical constituents. So this is about solid content. So let's see. If we use TS mean, that is total solid, you have to remember these things: total volatile solids, total fixed solid, total suspended solids. Likewise, there are some characteristics. We'll see this in the next lecture. Then alkalinity. Alkalinity in wastewater results from the presence of hydroxide, bicarbonate, bicarbonate of elements such as calcium, magnesium, sodium and potassium and ammonia. So this is the equation that we use to calculate the alkalinity of a water sample. So here that we have to reduce the H plus concentration. Okay, you can check, you can refer these things. You will learn, you will use this calculation in your practical class. Then next most important chemical characteristics in wastewater is BOD. That means we use BOD to calculate the effectiveness of a wastewater treatment plant. We say the effluent, influent wastewater, influent BOD is 1000 and effluent wastewater is 50 to calculate, to assess the, to show the effectiveness of the or efficiency of the wastewater treatment plant. Okay. So BOD is the amount of oxygen required to degrade the organic matter present in the water biologically, or the amount of dissolved oxygen needed by aerobic biological organisms in a body of water to break down organic material present in a given water sample at a certain temperature over a specific time period. That means BOD depends on the temperature and the time period. So here, what happens if there are oxygen and the microorganisms in the water? If there are organic matter in the wastewater, the microorganism will degrade. What is degradation? What is decomposition? There are organic matter. Organic matter consists of carbon, hydrogen, nitrogen. There may be sulfur. Then what happens? There are oxygen, presence of oxygen. Then microbes, microorganisms. Microorganisms convert these organic matter into simple byproducts: CO2, H2O, okay, CO2 plus H2O plus non-degradable matter, okay, non-degradable matter. So this is the degradation process. If there are organic matter in the wastewater, they will be degraded into, broken down into CO2, H2O and non-degradable matter by microorganism with the presence of oxygen. So that means if the BOD value is high, mean the oxygen demand is high. That means amount of oxygen required to degrade the organic matter in the wastewater sample is high. BOD is high. That BOD high means the presence of organic matter is high. Okay. So let's see what is the value of BOD in tolerance limits that we learned in our previous lectures. Okay, so here So this is tolerance limit for discharge of industrial waste into inland surface water. Here we see BOD, BOD 5, BOD 3, it is 30. Then we'll see in our next tolerance standard, it is BOD. BOD value is 250, and here BOD value is 250, COD value is 400. Then this is the tolerance limits of rubber factories discharge from inland surface water. BOD is 50 and 60, and COD value is 400 and 400. Now you can see in our tolerance limits, there were BOD 5 and BOD 3. BOD 5 is measured in 20 Celsius. BOD 3 is measured in 27 Celsius. That means BOD is depend on temperature and the time period. I will go to the that slide again. Here you can see BOD 5 is measured at 20 Celsius, BOD 3 is measured at 27 Celsius. It is an international standard. And also you can understand that at higher temperature, at 27 Celsius temperature, the rate of degradation or rate of breaking down of organic matter into simple byproducts is higher than that of the rate of the degradation process in low temperature. Therefore, at 27 Celsius temperature, the BOD is taken only for three days. The time period is 3 days. But for the low temperature, 20 Celsius time period, BOD is taken only for 5 days, for a longer period. Then let's see what is COD. COD is the amount of oxygen required to degrade the organic matter present in the water chemically. In BOD, you learn amount of oxygen required to degrade the organic matter biologically. But COD means chemical oxygen demand. The organic matter presence in the water is trying to degrade using a chemical dichromate. So in standard experimental method, we use potassium dichromate to degrade the organic matter in the wastewater. So what happened during the degradation? Organic matter is the carbon, hydrogen, oxygen and nitrogen. They will be converted into CO2, H2O and NH ammonia, ammonium ion. In the biological reaction also, here I forgot to tell, if there are nitrogen in the organic matter, they will be converted into ammonia, ammonium ion. If there are sulfur, they will be converted into H2SO4, sulfate. Then you have to find these things. Now you know what is BOD and what is COD, but BOD value is lesser than COD. Okay, even in tolerance limits also you can check. Let's see, let's go to the tolerance limits again. Here you okay, here these are the tolerance limits for discharge of industrial waste into surface water, schedule 1. So here BOD value is 30, chemical oxygen demand is 250. When we discharge treated wastewater into an inland surface water, BOD value should not exceed 30 milligram per liter, and the BOD value should not exceed the 250 milligram per liter. So, but here you can see the BOD value is lesser than the COD value. Yeah, what is the reason for that? And there's another one, BOD 5. What is the reason for 5? Okay, so at 20 Celsius, we'll do the experiment for 5 days. So when if we uh, do the BOD experiment for a 5 day, it is called as BOD 5. If we do the experiment for 3 days, it is called as BOD 3. So usually BOD 3 is measured in 27 Celsius. BOD 5 is measured in 20 Celsius. What is the reason for 5 days?